Okay, so we're going to do the combined gas laws. So 11.6. Should I use the combined gas law to find final pressure, volume, or temperature of a gas when changes in two of these properties are given and the amount of gas is constant? So the combined gas law puts the previous gas laws together, gives you a pressure, volume, temperature relationship for gases previously studied. It's useful for studying the effect of changes in two of these variables on the third, while the amount remains constant. So here's your formula. P1 V1 over T1 equals P2 V2 over T2. The amount of gas stays constant. Here's a review of your gas laws. Boyle's law, related pressure and volume. Charles's law, volume and temperature. Gay-Lussac's law, pressure and temperature. So if you combine all of these, you get your combined gas laws. First problem, helium gas has a volume of 0.18 liters, a pressure of 0.8 atmospheres, a temperature of 29 degrees Celsius. At what temperature, degrees Celsius, will the gas have a volume of 90 milliliters and a pressure of 3.2 atmospheres? So as you can see, we're going to have to change our temperatures to Kelvin. The volume and pressure, the units don't matter as long as they're the same. So first we're going to do our data into initial and final. So initials are givens. Pressure 0.8 atmospheres, volume 0.18 liters. Multiply that by 1,000 to get 180 milliliters so that these volumes are in the same units. Temperature changed to Kelvin. Final conditions, pressures 3.2 atmospheres, volume 90 milliliters, and we're looking for the temperature. Now we're going to rearrange to find the unknown variable. In this case, it is T2. To get that by itself, we just cross multiply. So T2 times P1 V1, T1 times P2 V2. And then we divide by P1 V1 to get the T2 by itself, which is what you want. Always do that before you put numbers in. Now we just plug in our numbers, 3.2 atmospheres, 90 milliliters, 302 Kelvin, divided by 0.8 atmospheres times 180 milliliters. Be careful with your math here, make sure you multiply before you divide that. Your answer is in kelvins, but the question asks for degrees Celsius for your final temperature. Subtract 273 to get 331 degrees Celsius. Second problem, a gas has a volume of 675 milliliters at 35 degrees Celsius, 0.85 atmospheres. What is the volume of the gas at negative 95 degrees Celsius and a pressure of 802 millimeters of mercury? Notice that you've got millimeters of mercury and atmospheres. You're just going to pick one and convert your units using that 1 atmosphere is 760 millimeters of mercury. So now we're going to organize your data. Your P1, V1, T1. Here we've got 35 degrees Celsius changed to Kelvin. You're looking for V2. Again, change this temperature to Celsius or to Kelvin. Rearrange for the unit that you're looking for. In this case, V2. So, to get V2 by itself, we can multiply by the reciprocal over here. So T2 over P2, which is what they did here. To cancel out these T2s and P2s. And then you get V2 is P1 V1 T2 over P2 T1. So again, you just multiplied by the reciprocal so that you could cancel these out. Or you could cross multiply and divide, whichever one you feel more comfortable doing. And then the last thing to do is plug in your numbers. 675 milliliters. We use millimeters of mercury here, which is fine as long as they're both in millimeters of mercury. And then your temperatures, we get 314 milliliters. Basically, these are mostly converting back and forth between your pressure units or your temperature units, and then making sure that you solve for the correct variable and that your answer is in the units that they ask you. So be careful with that. Hope this helps, and I hope you like my awesome gas mask. If you're curious, I can tell you how to do it. It works in Google Chat and Zoom as well. So, yay!